Good morning, listeners. I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology. Today's topic is pre-stressed concrete. As you know, this course is in 6th semester of your DCLG program, and this course contains 7 units. So in previous unit, we told you about the generic system of pre-stressing, that what pre-stressing is, why pre-stressing is done, what are its advantages, and where it is best suited. So to recapitulate, I'll begin with just what is pre-stressing. As you know, concrete members are subjected to various type of stresses, and in these stresses we have to be very careful about the tensile stresses. In your course of RCC design and other courses related to concrete, you have read that concrete is very strong in compression, but it is very weak in tension. Means it cannot take tensile stresses. Whenever plain cement concrete is subjected to tensile stresses, it develops crack and it fails because it is weak in tension. Then you know that solution for that is to reinforce the concrete. Means to bear the tensile stresses, we provide reinforcement to the concrete, and then it is called reinforced cement concrete. And in most of the cases, our problem of bearing the tensile stresses is solved. But as you know that for all cases, in all cases, this solution may work or may not work. If it works, then it may be uneconomical. So these situations may be like when the member is very long and it is subjected to heavy loads. When a member is very long and subjected to heavy load, or a member is not very long but it is subjected to heavy loads, then it's in such conditions again the tensile stresses may cross the limit to which a member has been designed. Then again same question comes in our way of providing the safe and stable structures. Then in such situations, what to do? So in such situations, our pre-stressed concrete design helps us in such situations. How it helps? In pre-stressed concrete, as it is clear from its name, the stresses are induced before external load comes to the structure or the structural member. Means we are providing internal stresses in the structural member which are in nature to opposite the type of stresses that are going to be developed in the structural member when it is subjected to external load. Then what type of stresses? In general, reinforcement is provided to bear the tensile stresses, and concrete is strong in compression. So here if we provide stresses, internal stresses of compressive nature in the beginning or before the external load come on the structural member, then we can solve some problem, because the portion which is going to bear the tensile stresses is now already in compression. So when the tensile stresses will come to the structural member, when the external load will be applied, then in that case the previously inserted or generated compressive stresses will counter the tensile stresses, and thus our structure or structural member becomes safe. Means the limit for the tensile stresses is not crossed. So this is the way how the structural members subjected to heavy loads or long in its dimension can be made safe. So this is called, this inducing of these stresses, internal stresses in the structural members is called pre-stressing. As you know, pre-stressing is done in two ways: pre-tensioning and post-tensioning. Pre-tensioning means when we are providing, we are inducing internal stresses at the time of casting of the structural member, then it is called pre-tensioned members, and the process is called pre-tensioning. Second method is that first the member is cast, a duct is left at the time of the casting of the member, then we induce these internal stresses, then this type of pre-tensioning is called, this type of tensioning is called post-tensioning, means tensioning after the casting of the structural member. So these are the two methods. So I have introduced you that what is pre-stressing, why it is needed, and how it is done in brief, means the basic concepts regarding this. As far as the example of this or the mechanism of this pre-stressing is concerned, you can simulate this mechanism to the mechanism of putting a steel wheel in case of horse cart. Means a steel ring is provided on the wheel of the horse cart, and you know the process. First that steel ring is heated, so by heating its diameter is increased, and in heated situation it is put on the wooden wheel, and then it is cooled. So what happens that when it cools, diameter decreases and it hold the wooden wheel with a tight grip, and it is applying the stresses on that. So this is a similar situation here, that we are providing stresses in advance through devices in which the wires or the strands are used, and those stresses, those stretched tendons apply the compressive stresses on the structural members. So this is one example of the similar situation or similar system to this pre-stress process. Now the question arises that how these stresses are induced in the structural members. What are the different methods? What are the different devices to induce these stresses in the structural members? Devices which we use for tensioning are of 4 types. First is mechanical devices, second is hydraulic devices, third is thermal or electrical devices. Though it is thermal or electrical, but the basic concept is same. The method how that thermal energy is provided, that is different. Based on that, these two names are there, thermal or electrical. Otherwise the action is same of the two devices here. And last is chemical devices. So these are the 4 devices or 4 ways to for tensioning of the structural members. We will take one by one of these 4 devices. First of all, I take the mechanical devices. So as the name is clear, mechanical devices means we are using some mechanical tools for tensioning the strands or the wires. Because here the stresses are induced or generated in a strand. Strand, you understand? Strand is a rope type of thing of steel in which there are many wires of small diameters. So it is a steel rope type of thing made of a number of wires of small diameters. So that is called a strand. In some cases, in pre-stressing process, we use single wire of large diameter also, but generally strands are preferred. So these strands are stretched or stresses are generated in these strands, and these stresses generated in the strand thereby generates stresses in the structural member. It passes its stresses to the structural member, and of course an opposite nature of stress is produced in the structural member, because these strands will be in tension, so compressive stresses will be generated in the structural member. So first device in this mechanical devices is jacks. Jacks may be of 2 types, jacks with lever or jacks with gear transmission. So you are familiar with the jacks. Generally for various purposes these jacks are used for mechanical processes. You are familiar with the car jacks and other type of jacks. So similar type of jacks, and of course of higher strength, are used here, and these are of 2 types, jacks with lever and jacks with gear transmission. Second type of mechanical device is screw jacks and wire winding machines. So this device is also used for pre-stressing or providing the tension in the strands. So these are the two devices which comes under the category of mechanical devices. Second type of device is hydraulic devices. So as it is clear from its name, hydraulic mechanism is used. So hydraulic jacks are used which works on the basis of the hydraulic mechanisms. So these, when we apply the stresses or generates stresses in the strands using the hydraulic jacks, then this device is called as hydraulic devices. So these are the two type of devices, mechanical devices and the hydraulic devices. In both type of devices, as you see, we are using jacks. The difference is only the mechanism of the jacks. In mechanical devices, we are using jacks with lever or gear transmission. In second type of devices, we are using hydraulic jacks. Now here you would like to know that how we will measure that how much force is provided or how much force is generated, how much tension is generated in the strands. So for that purpose, we use the pressure gauges, and these pressure gauges are calibrated. So when you are providing the stresses to the strands, so these calibrated pressure gauges are fitted there, and you can very well know that how much stress you have given to the strand, up to what extent, up to what limit your tendon has been tensioned, how much force has been provided. So this way you can know the force that you have given to the tendon. Because this measurement is very much necessary, because if you are providing stresses more than the calculated or less than the calculated, in both the cases our purpose is not solved. Because if it is under stressed, then tensile stresses will come into the picture in the structural members. If it is overstressed, then it will cross the limit of the compressive stresses. So that way we first calculate that how much force is required for pre-tensioning of a particular member for bearing a given calculated load. Based on that calculation, we use these devices to produce the stress in the tendons. So we have to be very accurate in providing the stress to the tendons, and we have to provide the calculated or pre-decided force in the tendon that way. So because of that, this measurement is very much necessary, because it is not arbitrary. Here you see a monostrand jack. This is the full picture of that monostrand jack here, and this is the wire or strand as shown in a separate hole. This strand is passing through, and this is the member, structural member. So this is the concrete member, and this is strand. You see here the split cone. These are some devices which are used to hold the strand at the end of this strand, because otherwise, if this is you see here the duct or the hole, so this has to be this strand has to be stopped here or fixed here by some these split cones and other mechanisms. So this is the monostrand jacks, which is used to provide the stresses in the structural members. Second type, and in this picture this mono strand jack means it can provide the stresses for a single strand. It can transfer the stresses for a single strand, but the jacks are available which can stress more than one strand, and you see here a multi-strand jack. This is the jack here, this is the structural member, here it is a duct, a number of strands you see here, these are strands. So these strands are being stressed using the multi-strand jack. So you can provide the stresses for more than one strand at a time. So for that you have to use a multi-strand jack, as the name, it is clear from its name. Now mechanism, that how it is done, how pre-tensioning is done. So what happens, that jacks are provided either at the both ends of the strand, or you can use jack on one side only also. So in first case, when jacks are provided on both ends, so that stress is being transferred, or the force is being transferred from both ends. At both ends of the strand or the member, jacks are provided. So it is stressing the tendon from both ends. In second case, that is jacks at one side only. As it is clear, we are providing jack on one side only, and on the other side what we do, this other side of the tendon is fixed to a wall or anchorage block or a column. So we can use to fix the other end of the tendon. For that purpose we can tighten it or fix it to a wall or anchorage block especially prepared for this pre-stressing work, or to a column, and the force is applied from one jack at the strand from one end, and this other end of the tendon is fixed there. So these are the two mechanisms for providing providing the stresses in the tendon through these jacks. So this is the mechanism for providing the stresses through jacks in the strands. Now comes the third type of devices. Third type of devices, as I told you, is thermal or electrical devices. In thermal or electrical devices, what we do, as it is clear from its name, that thermal means heating. Here the heating comes into the picture. We are not providing stresses through jacks or some other device. What we are doing here, that we will be heating the tendon. You can heat the tendon thermally or electrically. So by these two ways we are heating the tendon either thermally or electrically, and these are anchored in that tendon is anchored in the stretched form in the mold. Means when you are heating the tendon, then there will be expansion in the strand because it is made of steel only. So on heating it will expand, it will stretch. So in this heated condition, this tendon is stretched and anchored in the molds which are ready for casting of the structural member. Then what happens? Then that member is cast, and with time cooling occurs in the strands. When cooling occurs, you have already anchored both the ends of the tendon. So on cooling it will try to regain its length, but you have anchored these ends, so it will not allow the strands to shorten or to go into its original length. Then what happens means the stresses are developed, because that already it was stretched. On cooling it will try to shorten in length, but it is not allowed, so tensile stresses will be developed in the strands. And these stresses which have been developed on cooling of the heated strands, these stresses are used for the pre-stressing, and ultimately these stresses develops opposite nature of stresses in the structural member. So this is the way by which we generate the stresses in case of thermal or electrical devices. Fourth type of devices are chemical devices. What happens in chemical devices? Here tendons are not stretched either by jacks or thermally or electrically. Means we are not stretching the tendons directly. We are using some chemicals for what? For providing stresses in the structural member. And chemical which we generally use is, first of all, the cement in the cement concrete. We can use the expanding cement, means which on setting expands, or in addition to it we can use some chemical admixtures in the concrete. So what happens that when we are casting the structural member, we are using our expanding cement with or without chemical admixtures. So what is the action? That on setting, what happens that concrete expands, tries to expand, and in that situation what happens that strands which you have provided already in the structural member, it will elongate along with that, and by this process tensile stresses will be developed in the tendon. Now due to this expansion, tensile stresses are developed. Now we will provide the anchorages on the ends, and when this concrete or will hardened, then strand will be in tensile stresses and concrete member, structural member will be in compressive